Welcome everyone to the maths class. As we know, like this is our second class. In the last session, I have given you some small introduction about the overall subject, what topics we are going to study, and given a glimpse of the subtopics under it. And we have started linear algebra, and in first session we understood like the basic concepts of matrix which we have studied so far, like types of matrix, um, depending on the size of the matrix, depending on transpose, depending on uh, conjugate, okay, upper triangular, lower triangular, so on. Okay, and then we understood the concept of determinants, and we have started the concept of inverse, right? And in inverse topic, I remember we have studied couple of points there, how to calculate the inverse for 3 cross 3 matrix, 2 cross 2 matrix, and I guess we have solved um, maybe 2 questions on it. Yeah, yes. In today's session, we will continue that topic. um, I'll give you one other type of question which they can ask in exam. First type is like they will ask directly to calculate the inverse. Okay, and you know the procedure I have explained, and we have solved question also on it. Second one is like they'll give one equation and they'll say that a matrix A satisfies this equation, then find the value of A inverse. That type of question also we have solved. So multiply the equation on both the sides with A inverse, we'll get the value of A inverse. But there is one more type on which you can expect the questions, and that also will cover in um, today's session. And after that, we'll study some notes and then we'll go towards the rank of the matrix. Okay, so I'll go to the next slide. So first, uh, first let's just to test your understanding on matrix multiplication. Can you solve this first question? Mm, let me share my screen again. I think it got ended. I'll give you 1 or 2 more minutes. Okay, try to solve this first question and tell me the answer for it. Okay. Yeah, are you able to see my screen?
No, sir.
No. Okay. Then let me just share again. Mm. Yeah, I hope now you can see. Take time, 1 or 2 more minutes, and solve this first question. Yeah, it's not that difficult. Should be able to solve it quickly. Tell me the order of this entire matrix. Yes, 2 cross 2 is the correct answer. Very simple. Matrix P is a 2 cross 3, so P transpose is a 3 cross 2. Okay, and this is 2 cross 3. X transpose is 3 cross 4. Y is 4 cross 3. Okay, so overall you will get 3 cross 3 matrix here. Multiply with the 2 cross 3 will end up with a 2 cross 3. And this 2 cross 3, 3 cross 2 will give you 2 cross 2, 6. Take a transpose of it, you'll end up with the same. Okay. Yeah. Coming towards the second question. So here, this is the third type of inverse question which I was talking about. They may ask this type of question in exam. Okay. So matrix G into A into F into B into E into C into D is equal to identity matrix. Then find the B inverse. Okay. These all are the matrices which are in multiplication, and you are supposed to calculate the B inverse of it. Yeah, Arjun, correct. You got the correct answer. Yeah, procedure is quite simple. Let me just explain you here. So if you take inverse on both the side, how it will look like? Inverse of, what is inverse of AB? B, A matrix A into B in. What is the inverse of this? Can you tell me? Huh? What is the inverse of this matrix? A into B, whole inverse. Anyone? Yes, correct, Vishal. It's a B inverse, A inverse. So if you use that approach here, what will get? D inverse, C inverse, E inverse, B inverse, F inverse, A inverse, G inverse, B, F, A, G inverse, right? Is equal to I inverse. Inverse of identity matrix is identity matrix itself, right? Is equal to identity matrix, right? So now this is your next equation which you have got by taking inverse on both the side. So in order, you just want this term and you want to remove all other terms. So what you will do? You will start multiplying, let's say, the other terms. If you multiply this matrix with the D, DD will get cancelled, correct? Then if you multiply with the C, C into C inverse will get cancelled. So you have to, I'm multiplying on both the sides, okay? If you multiply with E on both the sides, E and E inverse will get cancelled. The similar way, if you multiply with the G, G inverse and G will get cancelled. A inverse, and if you multiply with A inverse will get cancelled. If you multiply with F, F and F inverse will get cancelled. Okay, so ultimately what we will end up with is ECD IGF. I is identity matrix, so if you can ignore it. So either you can write it or you can ignore it. So but your sequence is like ECD GAF. Are you following these two questions? Anyone have any doubt in this? Okay. Feel free to ask doubt if you have. Before we jump into the rank of matrix, uh, just like I would like to give you some notes. So these are the notes you should know. First note is, if matrix A is symmetric, then A inverse is also symmetric and adjoint of A is also symmetric. Okay. because adjoint A is symmetric means A inverse also has to be symmetric. We are just dividing with a determinant, right? So take a note. A matrix A is symmetric means adjoint inverse is also symmetric. If A is skew symmetric, then adjoint and inverse is skew symmetric. And the same way you have to apply for the Hermitian matrix. If A is Hermitian matrix, then A inverse and adjoint A is also Hermitian matrix. And same way you have to apply for skew Hermitian matrix. If A is skew Hermitian matrix, then its inverse and adjoint is also skew Hermitian. Okay. So depending on A, your A inverse and adjoint of A will be same. If it is symmetric, all are symmetric. If it is skew symmetric, other two are also symmetric. If it is Hermitian, other two are also Hermitian. If it is skew Hermitian, other two are also skew Hermitian. Okay, these are the simple points which you should know. It will help you to quickly solve some theoretical questions. Okay. Yeah. Can I proceed to the next slide? The next point which we are going to start is rank of the matrix. Okay. The rank of matrix will help us in order to judge the type of solution the system of equations will have. Okay. One way of guessing the solution is knowing the determinant, right? If you know the determinant, like whether it's determinant exists or determinant does not exist, on that we can tell what kind of solutions we'll get for the system of equations. And other way of guessing it is calculating the rank. Okay, we will be studying this in detail when we study the uh, linear system of equation, homogeneous and non-homogeneous. Then you will understand clearly the importance of determinant and rank there. But that's why we are doing pre-processing of it. We are studying determinant and rank in order to apply this knowledge when we go to that topic. Okay, so as I said, rank will help us to solve the system of equations, to guess the answer. So what is the rank of the matrix? A number R is said to be rank of matrix A if it satisfies below condition. Okay, there are two conditions. There are two conditions which are given, and if the matrix satisfies, sorry, if that number R satisfies these two conditions, then that number R is a rank of the matrix. Okay. Yeah. So the first condition is there exists at least one non-zero minor of order R. You know the term minor, cofactor, and all. Okay. So minor is what? So if we have, let's say, A1, A2, A3, B1, B2, B3, C1, C2, C3. Minor of A1 is this. Okay. B2, B3, C2, C3 is minor of A1, right? So what I'm saying is there exists at least one non-zero minor of order R. So let's say minor of 2 cross 2 exists. Maximum order of minor is 2 cross 2. It means the rank will be 2. Okay, this is first criteria. Second one is if there exists any minor of order n plus 1 or more, they must be 0. Okay, so what the meaning of it is, the other terms inside that matrix apart from that minor should be 0. Okay, let me try to explain you through some examples. Let's take this simple example 1 1 1 1 1 1 1 1 1. It's a 3 cross 3 matrix. If you convert this into echelon form, I'll explain what is echelon form in the upcoming slide. So after performing row operations, and what we'll get is 1 1 1 0 0 0 and 0 0 0, right? If you perform operation that R2 is equal to R2 minus R1, R3 is equal to R3 minus R1, we'll get this. So this is a 3 cross 3 matrix. Okay. And so here this is one also, this is one minor. Fine. This 3 cross 3 is also entirely one minor, but ultimately it's a 0, right? If you take a determinant of it, it's going to become 0. What is determinant of this matrix? Is 0, right? So what they are saying is there exists at least one non-zero minor of order R. So this is small term is one minor. Okay, this particular one term. In simple words, what you can say, the definition of rank is, if you find these 2 points are difficult, is number of non-zero rows, in echelon form of the matrix. Okay, so this is more common example which we see in the books. Okay, but ultimately whatever 2 things we are saying, they are indirectly what we are capturing here. Okay, so you can clearly see here number of non-zero rows are 1, right? Because this and this row is 0, second and third, so only one row is non-zero, first row. So rank of this matrix is denoted by row of A, or you can also write it as R, and the value is 1 in this case, right? Because number of non-zero rows in the echelon form of the matrix is 1. And let's check that this one is satisfying the criteria. There exists at least one non-zero minor of order R. Yes, this is the minor which I am circling. Okay, so this is also minor and this is also minor. So ultimately there exists at least one minor of order R. Okay, and if there exists other minor of R plus 1, that is order 2 or order 3, that is 0, because you take a determinant, you will get a 0 value. Okay, so indirectly we are saying the same thing, but for the simplicity I would suggest you to just remember this definition. It's very simple and commonly used, that is number of non-zero rows in the echelon form of the matrix. Okay, so in order to judge the rank, or in order to calculate the rank, the basic step is to convert the given matrix into the echelon form of the matrix. Okay, so first our task is to find the echelon form of the matrix. Okay, how it look like?
Hello.
Yes.
Sir, actually, the second point, no.
Huh?
If there exists any minor of order n plus 1, is it r plus 1 or more? They must be 0.
Yes, it's R plus 1, right?
Yeah.
Correct it. It's R plus 1. Thank you. Okay, so here R is 1. 1 plus 1 is 2. So if we have a minor of 2 cross 2, it should be 0. Okay, that is what we are trying to say. Yes, so it's corrected. Here it's R. What is echelon form of the matrix? Echelon form of the matrix is like converting the matrix into a upper triangular matrix. Okay, so trying to convert the given matrix into upper triangular matrix such that the diagonal terms are unit. Okay, or 1 you can say. So 1 1 1. Okay, during your university exams or college exam, you might have prepared the matrix into echelon form. But from the gate perspective, we will not like follow all that like procedure entirely. Our aim is to solve the question quickly. Okay, if it's fine if you don't make it 1. Okay, but the definition is like this. So we have all other terms 0, and x, y, z can be any other numbers. So if we are converting a given matrix into this kind of matrix, okay, in this case this can become 0, this can also become 0, depending on the cases, right? So but our aim is like trying to convert the given matrix into the echelon form of the matrix. Okay, let's say matrix A, B, C, D, E, F, G, H, I. Okay, in general any matrix we are trying to convert, we have to try to convert this matrix into echelon form, which looks like this, and then calculate the number of non-zero rows. Okay, so if this is the case you are getting, then number of non-zero rows are how many? 3. So rank is 3. So if you when you are trying to convert into echelon form, if you get a matrix like this, 1 x y 0 1 z 0 0 0, so you were not able to make this one 0, this became 0. Okay, during converting it to the echelon form. So what will say? Rank is 2 because number of non-zero rows are 2. Okay, suppose for example, while converting this matrix into the echelon form, you will get something like this: 1 x y 0 0 0 0 0 0, and that's what we have got, right, in this in the example which I have given. So in this case, 2 rows became 0, so rank is 1 in this case. Okay, rank is 3 in this case, and rank is 2. So what we can understand is rank will be at least 1. Okay, or at most size of the matrix, which is n. Okay, it's a 3 cross 3 matrix, so let's say n is equal to 3 in this case. So a 3 cross 3 matrix, rank will lie in between 1 to 3. Either it can be 1, 2, or 3. Okay, but for every matrix, rank exists. Is it clear till this? Before we proceed further on some details of the echelon form of the matrix, I'll give you the procedure. Yeah, but this is how it will look like. Let me just yeah, this is the slide we can refer. So yeah, so as I said, like I have given you 3 cross 3 matrix example. This is a 4 cross 4 matrix example. Okay, A B C D E F G H I J K L, and what we have to do is generally we perform row operation. So perform the row operation into it and try to convert this matrix into the echelon form. Echelon form is like a upper triangular matrix. Okay, the x terms can be 0, can be non-zero. We don't know. Okay, depending on the question, it will be different. Okay, so when we say our matrix is in the echelon form, if it satisfies these 3 conditions, we'll say matrix is in the echelon form. What is the first condition? 0 row, if any, they must follow non-zero rows. Okay, so if we have a 0 row, it should be at the end of the matrix. Okay, it should be at the end. You should not write 0 row here. Okay, it should not be the case. 0 row, if any, you have to write at the bottom. It should follow non-zero rows. Okay, that is the first condition. First non-zero element in a non-zero row is 1. Okay, so this is non-zero row, so first element has to be 1. This is also non-zero row. For example, the first element has to be 1. The third, this is also non-zero row, first element has to be 1. And let's say this is also non-zero, then the first non-zero element in the non-zero row has to be 1. Okay, if it is 0 row, that's fine. Okay, but as we can see that, let's say this x values are, for example, non-zero, then the first non-zero element in the non-zero row is 1. Okay, this is a standard standard, we can say, definition. But in gate exam, if you try spending time in making this 1 1 1 and then making other 0, like what we do in our college exam, it takes a lot of time, right? So here we have to take some shortcuts, because our ultimate aim is to not to write all steps, final answer, right? So it's fine if you don't make them 1 and directly perform the row and column operations. Third is like the number of rows before first non-zero element in a non-zero row are less than the number of such zeros in the next row. How many zeros are there in the first row? Zero number of zeros are there, right? We don't have any zero. In second row, how many zeros are there? 1. In the third row, we have 2. And the fourth row, we have 3 zeros. Okay, that is what it is saying. The number of zeros before the first non-zero element in a non-zero row are less than the such zeros in the next row. Okay, so this number has to increase. Okay, that is what the third condition says. In short, what I said is, if you are trying to convert a given matrix into the upper triangular matrix, that's your echelon form. You can these 3 points can be told in like a simple way, that try to convert a given matrix into a upper triangular matrix. That's all. Okay, if that is your aim, ultimately you will follow all these 3 points, and you will get the echelon form of the matrix. Is it clear to everyone, like how to if I give you example, will you be able to convert that into the echelon form? Yes. Okay, let me check. Yeah, before we jump into the questions, I would like to explain some points, and then I'll give you some questions to solve. So we have seen that example, right? 1 1 1 1 1 1 1 1 1. What is the rank of this matrix? And what is the determinant of this matrix? Fast. Rank is 1, determinant is 0, right? Fine. Let me give you another example. 1 2 3 4 5 6 7 8 1 2 3 2 4 6 5 minus 6 7. Okay, just a random. Okay, I'm just telling you that no, yeah, here rank of this matrix is 2. If you take a determinant, it will be 0. Okay, it will be 0. Okay, let me give you another example. 1 0 minus 2 minus 2 4 1 5 3 0. Rank of this matrix is 3 and determinant is non-zero. Okay, let's say this is already I have given to you. Okay, what do you understand from this? What do you understand from these 3 problems? You try to compare the solutions of it, and can you come up with some conclusion out of it?
Number of linearly independent rows or columns determines the rank of the matrix. We see the first matrix. So any row Yeah, linearly independent row is only one in the first matrix.
Yes, right.
The
Yeah,
second
in short,
matrix.
yeah, if you convert the echelon form, you will get number of non-zero rows are 1, and because as you said, linearly independent row will be 1 and rank of the matrix will be 1. Can you tell anything for determinant? In these two matrix, determinant is 0, but in third it's not non-zero. It's not 0. Yes, Vishal, if determinant is 0, rank is not equal to 1. Okay. If rank of the matrix is not equal to the size of the matrix, then determinant will be 0, because you will be able to convert that matrix into, or at least one row of that matrix you can make 0, because someone has said, like, in that case there is a possibility that there will not be n number of linearly independent equations. Okay, so all three may not be linearly independent, and there will be some dependency in between them, or there will be some ratio in between them, or in simple words, if you perform the row operation, you will be able to make at least one of the row 0, and because of it you are equal to number of unknowns. And as if any one of the row is 0, it means determinant is 0. Okay, so yes, correct. You guys are telling it correctly, Vishal and Arjun. So if rank of the matrix A is not equal to the size of the matrix, the determinant will be 0. Why? I have already told you that if rank is not equal to n means all the equations are not linearly independent. One of the equation will be dependent, or in simple words, if you perform the row operation, you will be able to make at least one row as 0. And if one row is 0 in your um, matrix, determinant is 0. If you remember, we have studied it clearly that even after performing the row operation, determinant will not change. Okay, if you are performing the operation and you will be able to make one of the row as 0, it means that matrix will have 0 determinant. Okay, I hope you are following it. Any doubt till this? Okay, let's try to consolidate all these things into a single slide. First slide, what I'm first point is rank of matrix A and A transpose is same. So if you take A or if you take a transpose, rank is going to be same. So ultimately, if you indirectly what we are saying, if you perform row operation or column operation, it's same. So, but simple words, we have practice of performing the row operation, so we'll follow it. But ultimately, what I'm saying is, if you perform the if you perform the rank calculation for A or A transpose, it will be same. Rank of 0 matrix is 0. If A is a non-zero matrix, then rank of that matrix will be always equal to or greater than 1. Okay, and rank will be always less than, less than or equal to size of the matrix. Okay, so rank is basically in this range. In short, it's greater than equal to 1, lesser than equal to size of the matrix. In short, rank of matrix is unique. You cannot have 2 ranks or 3 ranks for a single matrix. It's a unique value. Okay, and for every matrix, okay, rank exists. Okay, the next point, if A is a singular matrix, if A is a singular matrix, Singular means determinant equal to 0. Then as I said, rank is less than n. If A is a non-zero matrix, determinant is non-zero, then rank will be equal to number of size of the matrix basically. So we got very good relationship between determinant and rank now. Okay, you calculate the rank. If it is, or if you calculate the determinant, if it is 0, it's clear that rank is not equal to n. It's less than n. If determinant is non-zero, it's clear that rank will be equal to the size of the matrix. Clear? I hope you are ready for questions now. Yeah. Let me give you an example. You try to solve on your own and tell me the answer, and then I'll explain the solution. 1 1 4 5 minus 2 1 1 minus 7 minus 2 minus 5 2 minus 1 3 8 minus 1. Okay, the 4 cross 4 matrix. Solve this and tell me the rank. 1 1 4 5 minus 2 1 1 minus 7 1 minus 2 minus 5 and 2 minus 1 3 8 minus 1. Mm, 2, yes, rank. The rank is 2. Correct. Okay, let's solve this question. Yeah. So when we are trying to convert into the echelon form, we are trying to make this term 0, which I'm trying to which I'm circling now. Okay, so in the first step, what we'll do is we will make these 3 terms as 0. Okay, I'm making a circle around it. 1 2 and 3. So what operation you have to perform? R2 is equal to R2 plus 2 times R1. R3 should be equal to R3 minus R1, and R4 should be equal to R4 plus R1. Okay, so let's do it. After this first operation, what we'll do get is 1 1 4 5 0 0 0 1. This will become 1 plus 2 is 3 9 3. You will get this, you will get as minus 3 minus 9 and minus 3 after performing this operation, and the last row you are going to get is 4 12 and 4. So what you can see is like they are dependent Okay, in first and second row it's like a -1 multiplication. Okay, they are same basically. Okay, or in short, let me try to explain through simple step. If you write R2, if you divide R2 by, let's say, 3 and divide R3 by -3 and divide R4 by 4, what you are going to get is 1 1 4 5 0 1 3 1 0 1 3 1 0 1 3 1. So indirectly you can clearly see that these three rows are identical. And now if you perform the operation, R3 is equal to R3 minus R2 and R4 is equal to R4 minus R2, you will end up with, you can make this entire rows as 0 and 1 1 4 5 0 1. Okay, so this is your echelon form of the matrix. Number of non-zero rows are 2, hence rank is equal to 2. Okay, clear? Okay, let me give you another question. Can I proceed to the next slide? One minus 1 0 3 4 2 0 2 1 minus 1 0 3 1 minus 2 1 2. Okay, 1 minus 1 0 3 4 2 0 2 1 minus 1 0 3 1 minus 2 1 2. Find the rank of the matrix. Yeah, 3 is the correct answer. So R2, you want to make these three terms 0. So R2 is equal to R2 minus 4 times R1. R3 is R3 minus R1. R4 is R4 minus R1. 1 minus 1 0 3. This will become 0 0 0. Okay, after this operation, what about the other terms? 2 minus of minus 4 is 2 plus 4, which is 6. Similarly, if you do the calculation, you will get 0 and minus 10. Yeah, so these two rows are identical, just with a negative sign, so all are becoming 0. So if you subtract first and third row, you'll get third row as 0. So 0 minus 1 1 and minus 1. Okay, so this is not the echelon form, but at this stage we can judge the rank. So in this So you should not, let's say, follow like complete procedure. At this point, you have to think whether I'll be able to make any other row as 0 or not. It's one row is already 0. You cannot make this row 0. So compare row number 2 and 4 now, because those are the only ones which are remain. Can we make any of the row 0 by performing the row operation? No, because here it's 0 and here it's 1. If you perform any operation of addition or subtraction, basically these two are independent. So you cannot have any dependency you don't have any dependency in between them. Hence, at this stage itself, you can tell that rank of this matrix is 3 because number of non-zero rows are 3. Okay, and if you want to write the echelon form, how it will look like? It will take time. 1 minus 1 0 3 0 6 0 minus 10, then 0 minus 1 1 minus 1 0 0 0 0. Okay, then you have to make this as 1, this as 0, but ultimately you will realize that we cannot make any of these 3 rows as 0 by after performing, because anyway, see here, in this case, anyway this first row will not become 0. All right, so out of these and remaining these 2 rows, we don't have any dependency in them. So at this stage itself, you should judge and save your time for another questions. Okay, so that's why rank of this matrix is 3, because number of non-zero rows are 3. Is it clear? Let me give you another question. Zero zero minus 3, 9 3 y 3 1 1. Okay, solve this. This is little different question. You have to apply some logic to it. Okay, it's not straightforward. First element is 0 here. First element is generally 1, right? In the questions which I have given, first and second question. Okay, and in echelon form also, the condition is your first element has to be 1, but it's not necessary. Okay, as I said, you don't have to follow all the procedures, but it's sure that it has to be non-zero, because with a 0 you cannot perform the operation. So what you have to do is, yes, correct, Arjun, interchange the rows 1 and 3. So if it interchange the row 1 and 3, what will happen? Three 1 1. Okay, 9 3 5 0 0 minus 3. Okay, and now if you perform the operation, R2 is equal to R2 minus 3 times R1, what you will gonna get is 3 1 1 0, right? 3 1 1 0 0. 5 minus 3 is 2. 0 0 minus 3. Clear? And now there is a dependency in between them. So you can, if you perform the operation, R3 is equal to R3 minus, sorry, R3 plus 3 by 2 R2. You can make the third row 0, and ultimately what you get is 3 1 1 0 0 2 0 0 0. Okay, and after that we cannot make this to 0. Okay, or we cannot make any of the we cannot make the second row as 0 entirely. That's why at this point you have to stop and say rank of this matrix A is equal to 2, because number of non-zero rows are 2. Okay. Just to recall your understanding, if you perform the row operation, whether determinant will change, yes or no? If you perform the row operation, whether the determinant will change or not. Hello? Hello? Yeah, anyone? After performing the row operation, determinant change or not? No, it will not change. After interchanging the rows, what will happen to the determinant?
-1, sir.
Yeah, sign changes. Okay, sign changes, right? So that has to be clear. Okay, so that effect is for the determinants. For rank, nothing will happen. Okay, you can interchange the rows, but ultimately you have to make you have to be clear that if you perform the row interchange one time, your sign will change. If you interchange rows again sign will change. Okay, that is associated with the determinants. Okay, so these things has to be very clear. Just to remind again, uh, I brought this topic because in this question we have performed the same thing. Our rank is 2, but if you calculate the determinant, sign will change. Okay, so one thing you have to keep in mind, that whenever first element of the first row, that this is, if it is 0, you have to interchange the rows in order to solve the question. Okay, you have to let's say bring the smallest one, the element or the row in which first element which is smallest, you have to bring it to the top. Okay, in order to make the problem easier to solve. Okay, let me give you a few more questions. Can I proceed to the next slide? A matrix A which is n cross n such that A of ij is equal to I dot j then find rank of matrix A. Okay, solve this question. Okay, I'll repeat the question. A matrix A which is n cross n such that all the elements inside that matrix Aij is equal to I into j. Okay, I is a row number and j is a column number. Then find the rank of A. We got a question from Arjun. N cross n, all the elements are dependent to one another. Yes. So let me just show you how this matrix will look like. So
Answer is 1, sir.
rank is 1, right? Rank is 1. Let me just show you how this matrix will look like. I is row number, so first row. J is a column number, so first row will look like 1 into 1 is 1, 1 into 2 is 2, 1 into 3 is 3, 1 into 4 is 4, so on till 1 into n is n. Second row is 2 into 1 is 2, 2 into 2 is 4, 2 into 3 is 6, 2 into 4 is 8, so on till 2n. And 3 into 1 is 3, 3 into 2 is 6, 3 into 3 is 9, then 12, and so on till 3n. And this will have to go to n, 2n, 3n, 4n, and multiply by n. Okay, n into n. So you can clearly see first all rows are dependent with each other. So if I perform the operation here, like R2 is equal to, or R2 minus 2 times R1, R3 is equal to R3 minus 3 times R1. Okay, and same as Rn is equal to Rn minus 3 times n times R1. You will be able to make all these rows as 0. Okay, so rank of the matrix. So in short, your matrix will look like this: 1, 2, 3, so until n, 0, 0, 0, 0. Okay, like this it will look like. So number of non-zero rows is 1. That's why rank of the matrix is 1. Okay. Let me give you another question here. A n cross n such that Aij is equal to 1 if I is not if I is equal to j, Aij is equal to 0 if I is not equal to j. Find rank of the matrix. Okay, find the solution for the second question. It's not that difficult. Yes, it's identity matrix. 1 0 0 0 1 0. What is the rank of the identity matrix? It's 3 let's say n cross n identity matrix. So what is the rank? N. Correct. Okay. I hope you are following these questions. So these kind of questions you can expect from the rank. So let me just take you to the another topic where we will implement this concept of rank and determinant in order to solve the linear system of equations and see what kind of solutions we'll get. So write down heading linear equations. Write down heading linear equations. The linear equations can be homogeneous or non-homogeneous. Homogeneous means on right hand side it's equal to 0. That is you can clearly see in this equations a11 x1 plus a12 x2 plus so on till a1 and xn equal to 0. Okay, so we have equal to 0 here. If it is equal to 0, you can say it's a homogeneous equation. If it is not equal to 0, it's a non-homogeneous equation. Okay, so if it is homogeneous, let's see how to solve it. Can I write these equations, set of equations, into this matrix form where a11, a12, so on till a1n, a21, a22, a2n, am1, am2, so on till amn? This I can write it as a coefficient matrix A as shown here. Okay, so we have m number of equations. Okay, and n number of variables, or you can say unknowns. M number of equations and n number of variables. Okay, so the size of the coefficient matrix is m cross n. How many number of variables are there? N. So n cross 1 will be the size of matrix X, okay, which is unknown or which is a solution which we have to calculate. And so m cross n into n cross 1 will give you m cross 1 matrix. Okay, and that is 0. There is 0 matrix basically, all elements are 0. So first step you have to do is convert a given set of equations into the matrix form, which will look like as Ax equal to 0, where A is a coefficient matrix, X is a variable matrix or unknowns, and equal to 0. So X is equal to 0 is the first thing you should know. Clear? Okay. Now, in general, let's say focus on the matrix A only, okay, which is coefficient matrix. The rank of that matrix A can be equal to number of unknowns, or it may be so rank of that matrix A is maybe number of equal to number of variables n, or it will be less than number of variables, less than n. So these are the two possible cases, right? So if rank is equal to the n, then you can say it's a consistent. Okay, it's still consistent. And if rank is also not equal to number of the variable, then also it's a consistent. Okay, what is consistency and inconsistency? I'll explain you in a minute. Okay, after some time when we go to the non-homogeneous. Okay, at this stage, what we have to understand from this is, if rank is equal to number of variables, means number of variables is say 5 and our rank is 5. What rank defines number of non-zero rows, and what how many rows you will have? Number of equations means number of rows. So if you have 5 equations and 5 unknowns, it's a consistency, right? Means number of unknowns are equal to the number of variables. Sorry, number of unknowns equal to the number of equations. The problem can be solved, right? So that's why we are saying it as a consistent case. And if it is a perfect, that rank of the matrix equal to the number of unknowns, that is number of equations equal to the number of variables, in short, then you will get a unique solution, right? If I give you 2 equations and 2 unknowns, you will get a unique solution, right? But if I give you, let's say, 2 equations and 3 unknowns, what will happen? The solutions can be more, right? It can be infinite. So that is also consistent, say that you are getting solution, but it's not a unique solution. You are getting more and more solutions. In short, infinite number of solutions, right? So that is the second case here. That is rank of matrix A is less than the number of unknowns. Rank of the matrix A is less than number of unknowns means your equations are less than the variables. You will still get the solution, but they are infinite. That is the case. Okay. Yeah, Arjun, I'll repeat. So let's give you one simple example, Arjun. X plus 2y equal to 0. Can you tell me the values of x and y? Are you getting a unique value here? No, right? Because in this case, number of variables are 2, number of equations is 1. So m is, so this is the second case basically, correct? But if I give you one more equation here, let's say 2x plus 2x minus 4y equal to 5, something like this. Okay, then you may get a unique solution. Okay, you will get, because you have two equations and two unknowns, you will end up with a unique solution. Do you agree? So if m is equal to 2, n is equal to 2, you will get a unique solution. Are you following it? First understand the basics and then we'll go to this chart. If I give you two equations and two unknowns, whether you'll get a unique solution or not? Yes, right? And if I give you two equations and one, if I give you one equation and two unknowns like this, there will be infinite solution, right? For example, in this case, x plus 2y equal to 0. What does it means? X is equal to minus 2y. So depending on the value of y, x value will change. So y is 1, x is minus 2, y is 2, x is minus 4. If y is minus 4, x is plus 8. So depending on the value of x, value of y, x will also change. So basically you have infinite number of possible solutions in this case. Okay. So this is simple mathematics. Same logic we are applying here. I'll rub this and come to our chart now. If rank of the matrix equal to the number of variables, you will end up with a unique solution. Why? Because our rank means number of rows. Rank denotes m and number of variable denote n. Okay. If m is equal to n, that is number of equations and number of variables are same, you will get a unique solution. You can also call it as a zero solution and trivial solution. Okay. Whereas if rank is not equal to the number of variables, it is less than n. M is less than n. This is the case. Okay. M is less than n. In this case, number of equations are less, variables are more. Hence, you will get a infinite solution. Is it clear, this chart? Is this chart clear to you? The other way of writing it, can I say that rather than writing this term, rank of A is equal to number of variables, can I say if determinant is non-zero? And rather than writing this, can I say if determinant is not equal to 0? Will it affect? Because we know if determinant, sorry, I made a mistake. Here it should be 0. Okay, is that correct? Right? If I say if determinant is non-zero, means you will get a unique solution. If determinant is 0, you will get infinite number of solution. Is it correct? Yes, right? Yeah, because we know the relationship between rank and the determinant we have studied before. If rank is equal to the number of unknowns, determinant is non-zero. If rank is less than number of unknowns, determinant is zero. So you can also make a table like this. Okay. So if determinant is non-zero, you will get a unique solution. If determinant is zero, you will get an infinite number of solution. In both the cases, it is a consistent equation because you are getting a solution. When we say inconsistency, when you don't get the solution. Okay. So for example, if I give you let's say okay, we'll come to that okay afterwards. What is the inconsistency case? I'll explain you. Okay, can I proceed to the next slide? Let's first focus on the linear equations, homogeneous equations. Homogeneous equations are always constrained, but either you will get a unique solution or an infinite solution depending on your rank or the determinant. Let's solve some questions on this to make this concept robust. Yeah. For the equations, x plus y plus z equal to 0, 2x plus y minus z equal to 0, 3x plus 2y equal to 0, as first one, no solution, unique solution, infinite solution, zero solution. Okay, solve this. So first step, as I said, is you have to write the given set of equations into the matrix form. 1, 1, 1, 2, 1 minus 1, 3, 2, 0. Okay. X,
Unique
Y.
solution, sir.
Could you please repeat?
Answer is unique solution, sir.
No. 0, 0, 0. Let me read the question again. 1, 1, 1, 2, 1 minus 1, 3, 2, 0. Okay. If you realize we don't have any use of this as such. Okay. So don't waste time in like writing this. Directly write your matrix A. Okay. This is the first question, so I'm explaining in detail. But in your gate exam, you are not supposed to write things systematically like ax equal to 0 and waste your time. Okay. Ultimately, like you have to deal with A, check whether determinant of A or the rank of A, and on that basis you have to give the judgment. So focus on matrix A itself. Okay. Yeah, infinite number of solutions
Infinite
is
number of elements.
yes.
Yeah.
Okay. Why? Because if you calculate the determinant in this case, you'll get it 0. Okay. You can try to calculate determinant in this case, you'll get 0. 1 0 plus 2 minus 1 into 0 plus 3 plus 1 into 4 minus 3. So 2 plus 1, sorry, this is 2 minus 3 plus 1. 3 minus 3 is 0. That's all. Okay. Determinant is 0. So if determinant is 0 means in other way rank of the matrix is less than number of unknowns. Hence, in simple words, number of equations are less than the number of variables, and you will get the infinite solution. Okay, this is how you can compare. Can I proceed to the next slide? Yeah. Okay, little different question, but concept is same. Here 3 2 minus 1. So I'm skipping that stage. Okay, directly giving you the matrix, just to save our time. Lambda, but you know how to write, right? How to write the equation matrix from the equation. So lambda minus 14, 15, 1, 2, minus 3. Okay, x, y, z equal to 0, 0, 0. Okay, out of this is our matrix A, which is our focus. Has infinite number of solution. Find lambda. Okay, I'll repeat the question. This system of equations have infinite number of solution. Find the value of lambda. They are telling you upfront that number of solutions are infinite. The meaning of this is determinant equal to 0 or rank of A less than number of unknowns. Okay, so this is the meaning of infinite number of solutions. You know it. Use this hint in order to solve this question.
Five, sir. Lambda is 5.
Yes, perfect, right? Because calculate the determinant of the matrix is 0, and so it's a 3 into 14 multiplied by 3 minus 15 into 2 is 30, plus 2 into minus 3 lambda minus 15, plus 1 into 2 lambda plus 14. Okay, equate it to 0. Solve this, you'll end up with a lambda equal to 5. Yes, most of you have correctly solved it. Yeah. Okay, so the homogeneous equations were very comparatively simpler. Let's come to non-homogeneous equations now. Write down heading non-homogeneous equations. Non-homogeneous equations, as I said, will not have 0 on the right hand side. Means will have any non-zero terms at the right hand side. Okay, if the equations are such that on the right hand side of those you have non-zero terms, you have to call as a non-homogeneous equations. So a1 1 x1 plus a1 2 x2 plus so on till a1 and xn equal to d1. Okay, d1 is a non-zero term. So same way we have the set of equations. In previous case, we have written the set of equations in the ax equal to 0 form. Here we have to write into the ax equal to b form. Okay, A matrix is same, that is coefficient matrix. B matrix same, which is your solution matrix. Okay, and but the last matrix here is B. Okay, the last matrix here is B. Okay, A x equal to B. Okay, so non-homogeneous equations can be written in the form of Ax equal to B. One more term I would like to introduce here is augmented matrix. Augmented matrix means you are combining two matrices together. Okay, if matrix A is this, okay, if matrix A is this, B is this, the augmented matrix AB will look like this: A double dot B, and it can be written like this, or you can just write augmented matrix AB like this. We can put double dots, or you can avoid also. But if it is said that it's augmented matrix, means you're combining it. Okay. You can just draw a dotted line here to make it more clear that the matrix A and B are different. We are augmenting them. Okay. Why this term is introduced, I'll explain in the upcoming slides. This term is helpful to judge the solution of equations. Okay. Is it clear till this? I hope you understood how to write the system of equations in the matrix form and augmented matrix. If these two concepts are clear, it's very simple. So here the set of equation will look like as Ax equal to B form. Okay. In case of non-homogeneous equation, the set we have to write in the form of Ax equal to B. And then it's yeah. After this, what is our task is we have to judge the solution. Okay, we have to judge the solution. So Ax equal to B is our equation. Just a minute. My screen share got ended. Let me share again. Okay. Write down this table. I'll explain you in a minute. Yeah. So if rank of the matrix A and rank of AB is same, then that is a consistent case. That is consistent case. Okay. But if rank of AB is not equal to rank of A, it means it's an inconsistent case. And whenever we have inconsistent case, it means we have a no solution. What is inconsistent case? I'll explain you once again. Okay. So ultimately what you are doing is you're performing row operation, trying to make rows as 0. So you are able to make this last row as 0. So rank of A is, for example, 4, but you are not able to make this DM as 0. So rank of AB is 5. Are you following? Rank of A is 4 and rank of AB is 5. So it means you have 4 equations, 5 unknowns, and 5 terms. 1 2 3 4 5, 1 2 3 4 5, 5 terms here, but the equations are 4 itself. Are you following? So if I give you 2 equations, or let's say let me just explain in a better way. So though all the elements of this row are 0, okay, but see 1 2 3 4 5 elements of this row are 0. These are just a variable, but still you are getting a non-zero term here. Are you following? This is not possible, right? because if your entire row is 0, if you multiply with any of the variables here, okay, x, y, z, or let's say a, b, c, d, e, a, b, c, d, e, 0 multiplied by a plus 0 multiplied by b plus 0 multiplied by c plus 0 multiplied by d plus 0 multiplied by e will never be a non-zero. Okay. C, D, E, okay, is not equal to 0. It is not possible. Okay, correct. That's why it is inconsistent. If it is the case, we'll say it's inconsistent and then we'll not have a solution for it. Okay, so this is that case where rank of AB is not equal to rank of A. Means as I shown you, all the elements of that row are 0, but still you are getting some non-zero number in the B matrix. Okay, but if we rank of A equal to rank of AB, it's a consistent case, and depending on whether the rank is equal to n or not equal to n, you have unique solution or infinite solution. Okay, this you already know, we have studied in the linear. Okay, if rank is equal to the number of unknowns, you will get a unique solution. If rank is not equal to number of unknowns, you will get an infinite solution. Clear? Yeah. Can I proceed to the next slide? Same thing we can write in the determinant, but determinant thing in case of non-homogeneous equation is little complicated. So I suggest to follow this rank procedure itself. I'll explain you the procedure also, but my suggestion would be to follow this process only. Okay, coming towards determinant process. If determinant is not equal to 0, you will have a unique solution. It's clear always. But if determinant is 0, you can either have infinite solution or no solution. Okay. When we'll have infinite solution, if the value of d to d3 is 0, you will have a infinite solution. If any of this d1, d2, d3 is non-zero, you will have no solution. Now the question comes, what is this d1, d2, and d3? Okay, I will explain you in the next slide. Please write down this slide first and then I'll move towards next. Okay. Okay. If determinant is non-zero, you will have unique solution. If determinant is 0, you have to check whether d1 equal to d2 equal to d3 equal to 0 or not. If it is there, then you have infinite number of solution. Okay, but any of this d1, d2, d3 is non-zero, then you will have a no solution. I'll explain what is this d1, d2, and d3. Let's take this simple general case. We have three equations: a1x plus b1y plus c1z equal to d1, a2x plus b2y plus c2z equal to d2, a3x plus b3y plus c3z equal to d3. So a1, a2, a3, b1, b2, b3, c1, c2, c3 is your determinant, normal d. Okay, this you know, this is the d. Determinant is written as d. Okay, like this. So what is d1? If you replace first column by the right hand side vector, that is d1, d2, d3, then you call it as a d1. What is d2? If you replace the second column with the d1, d2, d3. And what is d3? If you replace the third column with d1, d2, d3. Okay, so keep this concept in your mind, that depending on which column we are replacing with a D1, D2, D3, we have to call it as capital D1, capital D2, and capital D3. Okay, accordingly. So if any of this determinant is non-zero, then you have no solution. If all the determinants are zero, then you have an infinite number of solutions. But yeah, if you think like this is little complicated, so how many times you have to calculate the determinant? You have to calculate the determinant once. If it is non-zero, you are lucky. You can directly say unique solution. But let's say unluckily you get a difficult question. Determinant is non-zero. Fine. Then you have to again calculate D1, D2, and D3. Okay. In order to make sure that every determinant is zero. Okay. So you ultimately have to solve 4 determinants, and calculating 4 determinants is a little time consuming. Okay. So rather than that, if you just focus on rank, calculate the rank on that basis. So just start working on calculating the rank of AB, augmented matrix AB itself. Write the augmented matrix and start solving it. You can directly get rank of A also within that. You don't have to work separately. Okay. So that's why I hope it's comparatively simpler, that if you calculate rank of augmented matrix, you will get rank of A also in that, and you can judge the type of solution you will get for this non-homogeneous set of equations. Okay. Is it clear till this? Any doubt? Should we proceed for some questions? Yeah. Okay. Let's take some question. Let me give you. X plus 2y plus 3z equal to 1. Two x plus y plus 3z equal to 2. Yx plus yy plus 9z equal to 4. Okay. Solve this system of equations. So how can we write this as in the matrix form? 1, 2, 3, 2, 1, 3, 5, 5, 9 into x, y, z equal to 1, 2, and 4. Okay.
Four solutions, sir.
Unique solution? Yes, correct. Why? You might have calculated the determinant. Determinant you will get non-zero. Okay.
No, sir. I just
Rank?
checked two equations became inconsistent.
Yeah, yeah. So you compared the equations and checked like whether they are
Consistent or inconsistent.
okay. Fine. So either way is you can calculate the rank or determinant. If you calculate the determinant in this case, you will get a non-zero number. Okay. Let's check it. 1 into minus 15 minus 2 into 18 minus 15 plus 3 into 10 minus 5. So it's minus 6 minus 6 plus 15. So 3, right? So 3 is a non-zero, so you can say it is a unique. If you calculate rank also, that's correct. Okay, you can still follow the process. Let's calculate the rank. Rank of the matrix, you should get it as 3. Okay, because unique solution you will get only when rank of augmented matrix AB. Sorry, yeah, augmented matrix AB equal to rank of A is equal to the number of unknowns. So let me just show you how to write the augmented matrix. So 1, 2, 3, 2, 1, 3, 5, 5, 9, dot, 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 like this, and then 1, 2, and 4. So directly write it like this. Okay, don't spend your time in writing AX equal to B and then augmented matrix AB. Directly take augmented matrix AB whenever you come across a non-homogeneous equation and start calculating the rank. What operation will perform? Rank of R2 is equal to R2 minus 2 times R1, trying to make this 0. R3 is equal to R3 minus 5 times R1, trying to make this 0. What will get? 1, 2, 3, dot, 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 1, 0, 0. Okay. 1 minus 4 is minus 3. 3 minus 6 is minus 3. 2 minus 2 is 0. Okay. 5 minus 10 sorry, yeah, 5 minus 10 is minus 5. 9 minus 15 minus 6, and 4 minus 5 is minus 1. So you can clearly see these two are independent. Okay, so you will not be able to make any of the rows 0 in this case. Hence rank of A equal to rank of AB equal to 3, which is size of the matrix. Hence you will have a unique solution. Okay, this way also you can judge, or you can judge through the determinant. Okay, let me give you another question. X plus 4y minus 2z equal to 3. 3x plus y plus 5z equal to 7. 2x plus 3y plus z equal to 5. Okay, x plus 4y minus 2z equal to 3. 3x plus y plus 5z equal to 7. 2x plus 3y plus z equal to 5. Solve this set of equations and get the type of solution you will get, whether you will get a unique solution, infinite solution, or no solution. Tell me. Can anyone tell me the answer? Okay, let me help you with it. So as I said, directly write the augmented matrix. Okay. Don't waste your time in calculating the rank of A separately or AB separately. Okay. So augmented matrix AB is equal to 1, 4, minus 2, 3, 3, 1, 5, 7, 2, 3, 2, 5. Yes, Vishal, no solution is the correct answer. Okay. So let's try to calculate the rank by converting into the echelon form. R2 is equal to R2 minus 3 times R1, and R3 is equal to R3 minus 2 times R1. 1, 4, minus 2, 3, 0, 0. 1 minus 12 is minus 11. Then this will become plus 11. This will then 7 minus 9 is minus 2. Minus 5 plus 5, 5 minus 6 minus 1. Okay. Yeah. So you can clearly see these two are dependent, or yeah, these two are dependent, but other two elements are not dependent. So for example, if I say R3 is equal to R3 minus 11 by 5 times R2, what will happen? One, 4 minus 2, 3, 0 minus 11, 11 minus 2. This will become 0. This will be also become 0, and this will also become 0. Correct? Yeah, sorry. Yes, it's 5 by 11. Correct. Thank you. Okay, because we are have to multiply with the 5 and then subtract. Okay, minus 5 by 11 times R2. So it's R3 is minus 1 minus 5 by 11 times minus 2. So it is minus 1 plus 10 by 11. So how much you will get? It's minus 1 by 11. So ultimately what we'll get is, this is your rank of E. Rank of matrix A is 2, and this entire is your rank AB is 3. So rank of A is less than rank of AB, correct? That's why, or rank of A is not equal to rank of AB. That's why you can say it's a no solution. Clear? Okay, determinant you want me to solve by using determinant method? Fine, we can try it. But as you know, like we have to calculate D1, D2, D3. Yeah, little time consuming. If you guys help me in by telling the answers, we will be able to solve it quickly. Okay. What is D1? 3, 7, 5, 4, 1, 3, minus 2, 5, 2. Tell me the determinant for this. D2, 1, 3, 2. Then 3, 7, 5, minus 2, 5.
Sir, A33 term is 1, sir. You return 2.
Yeah, sorry. Yes. Yeah. Let me repeat it once again. 3, 7, 5. Then 4, 1, 3, minus 2, 5. Okay. Okay, I understood. Okay. This is Z, this is 1, this 3, and this 1. Yep. Yeah. The answer is correct here. Okay. Just I written 1 in place of 2. Okay. Solution will not change here. Arjun, I hope you are asking this question. 1 minus of minus 5 is 1. Sorry, 1 minus of minus 4 means 1 plus 4. That's why 5 is written. So solution part is not wrong. Just replace this here to 1. Okay. Yeah. Now coming to the determinant type 3, 4, minus 2, 7, 1, 5, 5, 3, 1. Okay. The same way 1, 3, 2, 3, 7, 5, minus 2, 5, 1. Yeah. And D3 is determinant for where 1, 3, 2, 4, 1, 3, and 3, 7, 5. So to calculate all these 3 determinants, I hope at least one of this you'll get non-zero. Okay. If any of this is non-zero, our answer is correct. Let's find the D1. Yeah, Vishal got minus 2. Anyone else got minus 2 here? 3 into 1 minus 15. Someone is typing. Let's wait. D1 minus.
D1 0.
D1 0. What about D2 and D3?
D2 1, D3 0.
Yeah. So D2 is 1 means it's non-zero, right? So if at least any one of this D1, D2 is non-zero, you will have a no solution, right? We got a question from Arjun here. Since determinant is not equal to 0, then it can be unique. No, it's not for D1, D2, D3. It's for determinant of A. Okay, Arjun. So if you take a matrix A and its determinant is non-zero, then you will have a unique solution. Fine. But if determinant of matrix A is 0, and then if you check D1, D2, D3, okay, and if at least one of them is non-zero determinant, then it's a no solution. Are you following it? Yeah. Whatever you are saying is correct, but that is for A, not for the D1, D2, D3. Yeah. Okay, good. So this is the reason I am saying like this method is also fine, D1, D2, D3, but it will take a lot of time. As we saw, like some of you have solved it. D1 is 0, D3 is 1, and D3 is again 0. So you have to solve like determinant almost 4 times. You have to first solve determinant of A, then D1, D2, and D3. So almost 4 determinants means taking a lot of time. In place of that, you perform this row operations. Comparatively, I feel it will take less time. But yeah, you feel free to use any method which you find easy. Is it clear till this? Anyone have any doubt? If you have not understood anything here, feel free to ask. Okay. Then let me give you another question. I want you to solve this. Okay. X plus y plus z equal to 6. X plus 2y plus 3z equal to 10. X plus 2y plus lambda z equal to mu. Okay. If this set of equations have infinite number of solution, okay, what we are saying is this set of equations have infinite number of solution, then what is the value of lambda and mu? Okay, I'll repeat the question. We have the set of equations which are in the like 1 1 1 1 2 3 1 2 lambda, and the value b is 6 10 and mu. Okay, this set of equations have infinite number of solutions. Find the value of mu and lambda. They are telling you that system of equation is having infinite number of solution. Use that as a hint and calculate the value of mu and lambda. Yes, Arjun, mu is 10 and lambda is 3. So 3 and 10 is the correct answer. Good. You have solved it quickly. Let's solve it. I'll help for others. What is the meaning of infinite number of solution? Infinite number of solution means rank of, at least it is consistent, right? When it is consistent, AB equal to rank of A. It is consistent. Then only it will have solution, either unique or infinite. When it will have infinite, if rank of A equal to rank of AB is less than the number of unknowns, okay, or is less than the number of unknowns, or is not equal to number of unknowns. Okay, so number of unknowns are 3. Then for what values of mu and lambda, this is either 1 or 2. Okay, you have to check. Okay, let's come to this solution part. Okay, what they are saying is rank is less than 3 in short. Keep this in mind. Rank of A as well as AB. To perform the operation, R2 is equal to R2 minus R1. R3 is equal to R3 minus R1. 1 1 1 0 0. 2 minus 1 is 1. 3 minus 1 is 2. 2 minus 1 is 1. So lambda minus 1. Then you have 6. 10 minus 6 is 4. Mu minus 6. Yeah, 3 and 10 is the correct answer. Okay, we got this as your first trial. In the second trial, what you have to do, you have to make this 0. So what you will do, R3 is equal to R3 minus R2. Okay, so first row will become as it is 1 1 1 6 0 0. Second row will also become remain as it is 1 2 4. Third row will become 1 minus 12 will become 0. It will become lambda minus 3, mu minus 10. Okay, so if lambda is equal to 3 and mu is equal to 10, at that point only this term will become 0 and this term will become 0. And then only you can say rank of A equal to rank of AB equal to 2. Okay, if lambda is equal to 3 and mu equal to 10. Okay, this will become 0, this will become 0. So number of non-zero rows will be 2 only. Correct? I hope you are following it. Yeah. So you can expect this type of questions also. Find the value of lambda and mu. Yeah. So I think that's all we have for from this system of equations. I will, as we are at the end of the session, I don't want to start eigenvalues and eigenvectors topic. Okay, we'll just recall whatever we have studied till now. Okay, and then we'll end our session. So we started with the matrix theory. Okay, in that we understood different type of matrices like depending on size, rectangular matrix, square matrix. In square, we understood diagonal matrix, scalar matrix, identical matrix, okay, zero matrix. Then depending on the transpose, we understood symmetric, skew symmetric, depending on the transpose, we understood the Hermitian and skew Hermitian matrices. Then we understood the lower triangular and upper triangular matrices, right? So this was entirely type of matrix. We understood the concept of trace also. Trace means sum of the element of the principal diagonal. Then we understood the concept of determinants, inverse, and rank. We have also studied properties of all these things. Okay, so this is very important concepts, and we used it now in this topic of solution of system of equations. Okay, in this we implemented determinant, we implemented rank, and we understood how these two things are helping us to achieve the solution. Okay, so in the upcoming session, in the tomorrow's session, our aim is to use an eigenvectors. Eigenvalue and eigenvectors have good real-time applications in as you are from aerospace background, you know that what are the eigenfrequencies and mode shapes, right? Natural frequencies and mode shapes. So you know how to, you might have calculated frequencies and mode shapes in by the software or by writing code, and you will realize that back end of that works on the principle of this calculating the eigenvalues and eigenvectors. Eigenvalues represents the if you solve this equation, characteristics equation for the mathematical model of your um, system, the eigenvalues will end up with the natural frequencies and the mode shapes will be the eigenvectors. Okay, so this concept is very useful from the engineering point of view as well. Okay, so in the next class we will cover that eigenvalues, eigenvectors, and the last topic will be Cayley-Hamilton's theorem, okay, which is related to the eigenvalues, eigenvector itself. Okay, so that's all we have for today, and I hope in the first half of the tomorrow's session we'll be able to finish this chapter, and then we'll start the basic calculus. Okay, so Thank you all for joining today's session, and we'll meet again tomorrow. If you have any doubt till this, we can discuss now, or otherwise I'll end the session. Yeah.
The rank of matrix, we
Yeah.
have solved two problems actually. The second
Yeah.
problem, can you do that problem using the determinant method?
Which one?
Matrix 1 which started with 0,
Okay.
then we have interchanged that.
Yes, understood. Okay, let me just go to that. Yeah. So here the question is to calculate the rank.
Yeah. Using determinant, can we find out the rank?
No. You. Yeah. I understood your doubt, but problem is like determinant will tell whether rank is equal to number of unknowns or not. Okay. So let's calculate it first. Okay. What is the determinant of this matrix? What is the determinant of this matrix? 0, 0, and then you'll get 0, right?
0. Yeah.
But what does it imply? It implies the rank of this matrix is less than 3. It will not tell whether it's 1 or 2, right? But in exam, they may give you options like 1, 2, 3, and let's say can't find something like this. But you cannot say whether it's 1 or 2 unless and until you calculate it, right? So what I suggest you is like whenever they are asking you to find the rank, just calculate the rank. Whenever they are asking you to find the determinant, calculate the determinant. Don't go into the dependency of it. But when it comes to the some theoretical questions like or let's say the solution of system of equations, then you can implement that concept. Okay. Some questions are easy to solve with rank, some questions are easy to solve with the determinant. So for example, homogeneous equations, if you have, I feel determinant method is more better here. Like if you finding a determinant is for a single matrix is comparatively easy than finding the rank, right? But if you want to calculate determinant 4 times, it's difficult. So that's why I'm saying for homogeneous you can still use determinant method. Okay. Just find a determinant, tell whether it's unique solution or infinite solution. But if it is non-homogeneous equation, if you are using determinant method, there is a chance that you may end up with calculating 4 determinants here, one time, second, third, and 4 times, which is time consuming. That's why in this case I'm suggesting you to go through the rank. Okay, so in this cases only you have to do the connection, or you have to compare rank and determinant approach. But when they are asking you to calculate, you have to calculate it. You don't have like you in that case don't bring the dependency. Okay, I hope it's clear.
Okay, sir.
Okay, so anyone have any other doubt? Okay, no doubt, then we'll end our session here. Thank you all for joining this class, and let's meet again tomorrow.